Hello students, subscribers, and viewers. Here is another example on beams with support movements using the matrix approach and RISA, which I'm going to share with you. So by matrix approach and rapid interactive structural analysis software, determine all support reactions and the internal moments at B, C, D, and E. Support downward movements are A 5 mm, B 10 mm, C 13 mm, D 6 mm and E 2 mm. EI is 150 kilonewton meter square. So as a first step, so this is the drawn settled supports. So we compute fixed moments, fixed forces for AB, BC, CD, and DE respectively. So fixed moment AB due to support settlements or side sway, negative 6 EI. Delta, so remember delta is treated positive when the cord rotates clockwise as shown, AB, and delta is 10 minus 5 or 5 mm which is converted to meters, so 0.005 divided by L square, so negative 55.556 kilonewton meter, and this is also the fixed moment BA due to settlements or support movement. So negative means counterclockwise in slope deflection equation. That's the sign convention for slope deflection equation. But the results in the software here counterclockwise positive, especially for moments. By the way, when the beam is end supported, so the technique here, the final moments at A and at E, as long as they are the leftmost and the rightmost supports, would be final also, except for moments at B, C, and D which are not final. And remember also that the reactions, vertical reactions, will also be final after we apply these side sway moments together with the loads. So fixed moment BC due to settlements or side sway, which is also equal to fixed moment CB, is negative 6 EI. Delta is again treated positive here. 13 minus 10 is 3 mm or 0.003 meter divided by 7 square. The rotation is clockwise. So it is negative 55.102 kilonewton. So counterclockwise here. Then fixed moment CD, which is also fixed moment DC, is equal to negative 6 EI. Delta this time is treated negative because the rotation of CD is counterclockwise. And delta is 13 minus 6, so 7 mm, negative 0.007 meter divided by L square, 6 square, so positive 175 kilonewton meter. So it is applied clockwise as shown in portion CD. Then finally, fixed moment DE, fixed moment ED is equal to negative 6 EI. Delta is, the rotation is counterclockwise, treated negative 6 mm minus 2 mm is 4 mm, so negative 0.004 meter over L square 8 square, so 56.25 kilonewton meter positive, so clockwise as shown. Then we compute for the fixed forces due to these couples, only couples. The reaction due to the load will be automatically generated and analyzed by RISA here. So FA summation moment B, FAB times 9 equals 55.556 plus 55.556. So FAB is 55.556 times 2 divided by 9. So it is 12.346 kilonewtons and it is upward. So therefore, because this is due to the couple, the fixed force at B would be downward and equal in magnitude as this, as shown. So for fixed force BC, because the moments are due to side sway are counterclockwise, so it should produce clockwise moment about C. So FBC times 15.743 equals 55.102 times 2. So FBC is equal to FBC times 7. So FBC is 55.102 times 2 divided by 7, 15.743 kilonewtons, and it is upward at B just to the right, downward at C just to the left. Then next, because these couples are clockwise couples, so the fixed force at C just to the right should be such that it will produce counterclockwise movement. So it is downward. So fixed force is equal to 175 times 2 divided by 6, 58.333 kilonewtons. And at D just to the left, it is 58.333 kilonewtons upward. Then finally, at D, since these are clockwise couples, so therefore the fixed force should be downward to produce counterclockwise moment about E. So 56.25 times 2 divided by 8 is 14.062 kilonewtons downward here. So it should be upward at E, 14.062 kilonewtons. We then use RISA. Then this is the beam with the corresponding lengths of 9, 7, 6, and 8, and such that EI is equal to 150 kilonewton meter square. So I set I to be 750 times 10 to the 6 and E 200,000 megapascals in order to have that value. Then we apply the nodal loads. Remember, nodal loads are opposite to these fixed end forces. So at A, we have 12.346 upward, so it is now downward, negative 12.346. And the couple this is counterclockwise, positive in the software, so it is clockwise, so negative 55.556. So clockwise as shown. What is important, it is clockwise, opposite to this. Then at B, the load is 12.346, treat this positive, minus 15.743. So the result is negative because remember, the load is opposite to these fixed forces. So that's why I treat 12.346 positive minus 15.743 upward as negative, so that the net result, which is negative, should be the load here, which is supposedly downward, opposite to this greater magnitude force. So negative 3.397 kilonewton. And the load is the fixed moments at B, 55.556 plus 55.102 counterclockwise. Because these are counterclockwise, so the load is clockwise. Clockwise, the combined value, clockwise couple is negative in RISA. So negative 110.658. That's the combined value here, but clockwise. So negative 110.658 when you input the value in RISA. Then at here, at C, so we have 15.743 plus 58.333. That would be equal to, it's not seen here, but it should be use your calculator. 15.743 plus 58.333 is 74.076. So the magnitude of this load, upward load at C, is 74.076. That is 15.740 plus 58.333, so 74.076 here. Then next, we have 14.062 minus 58.33. So we have negative 44.271 load, vertical load at D. Then the couple, 175 clockwise plus 56.25 clockwise. So the load should be counterclockwise. The combined value is positive 231.25 kilonewton meter. Then finally at E, negative 14.062, opposite to this, and the couple is, this is counterclockwise, so this is clockwise rather, so it is counterclockwise, so positive 56.25. Counterclockwise positive in the software, remember, and that's also the correct sign convention. So having loaded the beam together with this fixed end, opposite to fixed end forces, loads and fixed end moments, then the generated value after you press solve on the menu would be these results. So these are the final reactions at A, vertical reactions at A, B, C, D, and E. So we have 59.618 kilonewtons upward at B, 240.155 kilonewtons upward at C, 75.896 kilonewtons upward at D, 118.835 kilonewtons upward, and at E, 9.496 kilonewtons upward. For the moments, as I said, for the end supports, that would be final. So moment at A is 0. Moment at E is negative 22.979, which is also equal to this, negative 22.979 kilonewton meter. But for the internal supports, B, C, D, we have to add the fixed forces. So moment at B, which is moment BC, therefore, is from the software, we have negative 137.335. Then we have to add this moment here for BC. This is counterclockwise, so minus 55.102. So the final moment at B is negative 192.47 kilonewton meter. This is actually clockwise rotation because counterclockwise moment is positive in the software. But that's the final value. These are also the answers and signs for analyzing this beam using three moment equations, slope deflection equations, and moment distribution equations, and any method, force method, or double integration method if not difficult for us to apply. Then moment at C is moment CD. We have negative 150.019, then plus 175. This is positive 175 clockwise because we base it from slope deflection equations. So moment at C is final 24.981 kilonewton meter. Moment at D is negative 153.259, then plus, this is plus 56.25. So that's why moment at D is negative 97.009 kilonewton meter, and moment at D is final negative 22.979 kilonewton meter. Moment at A final also, it is 0. So that's it for this video. I hope that you gain another technique, especially in using the software RISA and dealing with beams with support movements.